Students, I am Prashant B. Chandran, Assistant Professor Automobile Engineering Department, SNIT Adoor. Today, I am going to teach about these following topics. It is Wayne's displacement law, Stephen-Boltzmann's law, black, gray and real surfaces, configuration factor or shape factor. Okay. First of all, Wayne's displacement law. The law states that the wavelength corresponding to maximum spectral intensity is inversely proportional to absolute temperature. Once again, the law states that the wavelength corresponding to maximum spectral intensity is inversely proportional to the absolute temperature. Okay. Actually, this law is Wayne's displacement law, and this is the first law. Okay. That is this law is simply called as Wayne's displacement law, and if it is asked as the first law of Wayne's displacement law, you should answer this. Okay, this law. And that is lambda max proportional to 1 by T, where lambda max is the maximum spectral intensity of wavelength and T is the absolute temperature. It is lambda max into T is equal to a constant. That constant is 2.898 into 10 raised to minus 3, which is equal to 2.9 into 10 raised to minus 3 mk. Mk means meter Kelvin. Meter Kelvin. It is the unit of wavelength is meter, and that for temperature is Kelvin. Okay. The second law states that the maximum spectral intensity is directly proportional to fifth power of absolute temperature. That is, once again, the maximum spectral intensity is directly proportional to fifth power of the absolute temperature. Okay, maximum spectral intensity എന്ന് പറയുമ്പോൾ നമ്മൾ അതിനെ EB ലാംഡ മാക്സ് കൊണ്ട് റെപ്രസെൻ്റ് ചെയ്യും. അബ്സല്യൂട്ട് ടെമ്പറേച്ചർ എന്ന് പറയുന്നത് ക്യാപിറ്റൽ T ആണ്, നമുക്കറിയാം. അപ്പോൾ നമുക്കിതിനെ എങ്ങനെ എഴുതാമെന്നുള്ളത് വെച്ച് കഴിഞ്ഞാൽ നമുക്കിങ്ങനെ എഴുതാം. ദറ്റ് ഈസ് EB ലാംഡ മാക്സ് പ്രപ്പോർഷണൽ ടു T raised to 5. Actually, proportional to T raised to 5. And if we are removing the proportionality, then EB lambda max is equal to 1.285 into 10 raised to minus 5 T raised to 5. Okay, or which is equal to 1.307 into 10 raised to minus 5 T raised to 5 watt per meter square. Okay. Next one is Stephen-Boltzmann's law. The law states that the heat transfer is directly proportional to area and fourth power of the absolute temperature. Once again, the Stephen-Boltzmann's law says that heat transfer Q is directly proportional to area A and fourth power of absolute temperature, that is T raised to 4. Okay, heat transfer is directly proportional to area and fourth power of absolute temperature. This we can write that heat transfer, that is represented by capital Q, area capital A, absolute temperature capital T. That is Q proportional to A T raised to 4, where Q stands for heat transfer, A for area, and capital T for absolute temperature. And the proportionality constant, if we remove that, Q is equal to sigma A T raised to 4, where sigma is called as Stephen-Boltzmann's constant. Okay, and sigma is equal to 5.67 into 10 raised to minus 8 watt per meter square, Kelvin raised to 4. Sigma is the Stephen-Boltzmann's constant. Okay. Next topic is black, gray and real surfaces. Okay, first of all, black surface. A black surface is a surface that absorbs all the radiation falling on it. അതായത് ഏതെങ്കിലും ഒരു സർഫസിൽ വീഴുന്ന എല്ലാ റേഡിയേഷനെയും ആ സർഫസ് അബ്സോർവ് ചെയ്യുമെങ്കിൽ അങ്ങനെയുള്ള സർഫസിന് പറയുന്ന പേരാണ് ബ്ലാക്ക് സർഫസ് എന്ന് പറയുന്നത്. ഓക്കെ, is a black surface is a surface which absorbs all the radiations falling on it. Okay, അങ്ങനെയുള്ള സർഫസിന് നമ്മൾ പറയുന്ന പേരാണ് ബ്ലാക്ക് സർഫസ്. For a black surface, absorptivity alpha is equal to 1, but transmissivity and reflectivity are 0, both 0. Okay. The next is gray surface. We have already studied about black surface. The second one is gray surface. Okay. For a surface, if the radiative properties like alpha, rho and tau, that is absorptivity, reflectivity and transmissivity of okay, are uniform over the entire wavelength spectrum, then such a surface is called a gray surface. That is, for a surface, once again, for a surface, if the radiative properties alpha, beta, rho and tau are uniform over the entire wavelength, then such a surface is called as a gray surface. Okay, is it clear? അപ്പോൾ ഈ മൂന്ന് പ്രോപ്പർട്ടീസും ആൽഫ, റോ, ടോ എന്ന് പറയുന്ന മൂന്ന് റേഡിയേറ്റീവ് പ്രോപ്പർട്ടീസും ഇത് എൻ്റയർ വേവ് ലെങ്തിൽ ഈ മൂന്ന് പ്രോപ്പർട്ടീസ് യൂണിഫോം ആണെങ്കിൽ സച്ച് സർഫസ് ഇസ് കോൾഡ് ആസ് ഗ്രേ സർഫസ്. ഓക്കെ, ഇനി അടുത്തത് നമ്മുടെ റിയൽ സർഫസ് ആണ്. നെക്സ്റ്റ് വൺ ഈസ് റിയൽ സർഫസ്. വേറൊന്നുമില്ല, അബ്സോർപ്റ്റിവിറ്റി വേവ് ലെങ്തിനനുസരിച്ച് വേരി ആവുമെങ്കിൽ അങ്ങനെയുള്ള സർഫസിനെ പറയുന്ന പേരാണ് റിയൽ സർഫസ്. ദാറ്റ് ഈസ് ഫോർ എ റിയൽ സർഫസ് the absorptivity varies with wavelength of radiation. Okay, absorptivity wavelength of radiation അനുസരിച്ച് വേരി ആവുമെങ്കിൽ such a surface is called as a real surface. Another name for this is colored surface. Okay. Our next topic is shape factor. The other names of shape factor are view factor, configuration factor, or angle factor. Okay, all these are same. Shape factor. Shape factor is defined as a geometrical parameter which is the function of the area of receiving body, separation, and location. Okay, shape factor is a function of it is a geometrical parameter which is a function of the area of receiving body, the separation, that is the distance between the two bodies, and their respective location. Okay. It is denoted by usually F12, where F stands for shape factor, the digit 1 represents the emitting body, and 2 represents the absorbing body or the receiving body. Okay. Shape factor depends upon the following factors. Okay. Shape factor depends upon the following factors. Shape factor is directly proportional to area of the receiving body. It is shape factor is directly proportional to area of the receiving body. Okay, there are two bodies. One is the emitting body and another one is the receiving or absorbing body. Okay, shape factor is directly proportional to area of the receiving body, that is the absorbing body. Second one, shape factor is inversely proportional to separation, that is distance between these two bodies. Okay, shape factor is inversely proportional to separation, that is distance between these two bodies. Okay, third one, that is shape factor is more or high if these two bodies are kept just above one another. That is, if these two bodies, absorbing body, emitting body and absorbing body, are placed one above the other, the shape factor value will be high. Okay. Then, while considering various geometries like parallel plates, cylinders, spheres, etc., rectangles, etc.,